Hello everyone, welcome to our lecture number 16 of our first chapter electric charges and fields. So in this lecture we will discuss about Gauss theorem. Yes, so as per Gauss theorem, what is its statement? So this theorem tells that according to this law, remember, total flux means electric flux passing through closed Gaussian surface is equal to 1 by epsilon naught times the total charge enclosed by it. Yes, so as per this law, so this is, suppose think that this is Gaussian surface. What is Gaussian surface? I will tell, wait up to that moment. So let us consider this is our Gaussian surface, and inside this Gaussian surface, suppose q1, this is charge q2, up to qn number of charges are there. So what is the value of electric flux? So as per this theorem, phi is equals to q enclosed within the Gaussian surface divided by epsilon naught. That means phi is equals to q1 plus q2 up to qn divided by epsilon naught. This is the meaning of this Gauss law. Yes, so let's do this law, how phi is equal to q by epsilon naught. Okay, so let's come to its proof. Yes, let us think this is our charge q, source charge is q, and this red color surface, that is your spherical surface, this is your Gaussian surface. Let us think that this is your Gaussian surface, red color part is Gaussian surface, so we can name it as Gaussian surface with respect to q. Gaussian surface symmetrical, which is symmetrical with respect to q. So if you will write what is Gaussian surface, what you have to write? Simply you mention Gaussian surface is three-dimensional closed surface symmetrical with respect to charge, which is symmetrical with respect to charge. Okay, so what is Gaussian surface? It is clear. So it is a surface that is 3D surface or closed surface, 3D type closed surface, which is symmetrical with respect to charge. Yes, so as per our figure, let us consider a small area. The total surface area is A, that is 4 pi r square. The small area dA. So what will be the dA vector? Area vector will be outward normal. It is a part of closed surface, so outward sense gives the direction of area vector. And this is the radius. The radius is r. So if you will place a charge q naught upon this surface dA, so what will you observe? The electric field intensity direction is along outward direction. This is the direction of electric field vector. Yes, okay. So now tell what is the value of small flux through this element. Let small flux through this element is d phi. Let d phi is equals to flux through small element. Flux through small element. Yes. So what is the value of d phi? What you have to write? Thus d phi is equal to, as per the previous lecture, go through that lecture, electric flux, lecture number 15. So d phi is equals to E vector dot dA vector, that is E and dA, both the vectors are in same direction. So E dA cos 0 degree, that will be E dA only, E dA. So which implies d phi, we came to know it is equals to E into dA. So what will be the value of phi? So integrating both sides, you will get d phi integration equal to E dA integration. Yes, and d phi integration is phi, and integration of this is E constant, take it outside, and dA integration is integration of dA, which is equals to total surface area, that is E into A. What is A? A is the surface area of Gaussian sphere. Surface area of Gaussian sphere. I hope it is clear to all of you. So which implies we can write phi is equal to E into 4 pi small r square. Now tell what is the value of E? E is the electric field intensity at a distance r from charge small q. So we can write its value is k into small q divided by r square. kq by r square into 4 pi small r square. Now we can write what is the value of k? K is Coulomb's constant, that is 1 by 4 pi epsilon naught into q divided by r square into 4 pi small r square. Now after solving you will get 4 pi cancel out, r square cancel out. So final answer is phi is equals to q divided by epsilon naught. Now tell what is q? Q is the charge which is enclosed within the Gaussian sphere. Q is the charge which is enclosed within the Gaussian sphere. So we can write Q enclosed divided by epsilon naught. This is the value of flux. This is the value of flux through this Gaussian sphere. So phi is equal to Q enclosed by epsilon naught. So as per the proof, you may follow this process. Okay. So how phi is equal to Q enclosed by epsilon naught? It is clear to all of you? Yes. So let's come to some golden points regarding your Gauss theorem or Gauss law. This is fully important. So our first point is point number 1. See this thing. This is suppose charge Q and this is our Gaussian sphere. The Gaussian surface is this one. Yes. So let us think a charge is present outside. Capital Q charge is present outside the Gaussian sphere. So remember, outside charge is not taken because their net flux is 0. देखो a plus Q charge रू electric field lines बाहरला. Yes. Yes. So ये portion ने हमर कौन हैला? Flux in हैला. Opposite portion रे flux out हैला. So जतिक flux in सेतिक flux out. Flux inward हैला negative, flux outward positive. So net flux will be 0. So first point is outside charge. Outside charge is not taken because their net flux is 0. Because their net flux is 0. This is one golden point. Next point, point number 2. Suppose this is your Gaussian sphere. These are two Gaussian spheres. Consider these two examples or two diagrams. This is your Gaussian sphere. In one Gaussian sphere, in one case, in first diagram, the charge present at its center, and in second diagram, the charge is at this position. So position of charge is different in two diagrams. So remember, in first case, what is the value of electric flux? Phi is equals to Q by epsilon naught. In second case also, phi is equals to Q by epsilon naught. Okay. So from this we can write one point. Electric flux is independent of, it is independent of position of charge inside of Gaussian surface, inside of Gaussian sphere or Gaussian surface. Flux is independent of position of charge inside of Gaussian surface. One of the most interesting point. Next, come to another point. Yes. Okay. Next, come to our point number 3. What is that point? Point number 3. Let us consider 4 diagrams as per the figure. And last one is cylindrical shape. Yes. So in first case, the radius is r, the charge is present at the center. In second case, the Gaussian sphere is a sphere of radius 2r and charge is present at the center. And here charge is present inside the cube. Here charge is present inside the cylinder. So what is the value of flux in each case? So all of you remember, in first case flux is equals to q by epsilon naught. Second case also flux is equals to q by epsilon naught. In third case flux is q by epsilon naught, and in fourth case also flux is equals to q by epsilon naught. So one more interesting point, we came to know that flux is independent of shape and size of Gaussian surface. Shape and size of Gaussian surface. So remember, we have to consider about the charge enclosed within the Gaussian surface. Yes. Next point. Next is our point number 4. Point number 4 is, suppose this is your Gaussian sphere. This is our Gaussian sphere, and inside the Gaussian sphere 2 charges are there. They are minus q and plus q. Yes. So what is the flux value? So flux is equals to total charge q plus minus q divided by epsilon naught. So 0 by epsilon naught, that is equals to 0. So flux is 0. So remember, if flux through the Gaussian surface is 0, electric field may or may not be 0. Yes. Because plus q minus q डाइपोल क्रिएट कले तार इलेक्ट्रिक फील्ड अच्छी निहाती. सो इलेक्ट्रिक फील्ड कौन पारे, मे बी 0 और मे नॉट बी 0. यस. सो नेक्स्ट 4 नंबर पॉइंट इज, इफ फ्लक्स थ्रो Gaussian surface is 0, electric field may or may not be 0. May or may not be 0. बुझेला केसटा. बर्तमान कौन अच्छे टोटाल चार्ज के 0 किंतु इलेक्ट्रिक फील्ड अच्छी. टोटाल चार्ज 0 बट वी कैन से इलेक्ट्रिक फील्ड इज नॉट इक्वल टू 0. क्लियर. सो बर्तमान कौन कली ए थर्ड फोर्थ पॉइंट पाई मु आ गोटे डायग्राम कली. सपोज दिस इज योर Gaussian sphere. This is your Gaussian sphere, and within the Gaussian sphere no charge is present. किसी चार्ज बर्तमान ना ये Gaussian sphere भितर. बर्तमान इसे केते रहबो. So flux is equals to q enclosed by epsilon naught, that is 0, and so it implies electric field केते अछि 0. No charge means 0 electric field. This is one conclusion, this is another conclusion. Okay, go through these two conclusions. We can write, if flux through Gaussian surface is 0, then electric field may or may not be 0. May be 0 or may not be 0. In first case it is not equal to 0, in second case it is 0, but in both the cases flux is equal to 0. Then come to point number 5, it's reverse point. If electric field of Gaussian surface is 0, it means flux is 0. This is true. Yes. So the point is, if electric field of Gaussian surface is 0, it means flux is also 0. Flux is also 0. How? Let us consider this is your hollow conducting sphere. Hollow conducting sphere means when charge is given to the sphere, all the charges start to distribute among themselves uniformly on the surface of the sphere. And let us consider this is your Gaussian sphere. This is your Gaussian sphere. Yes. So this is your Gaussian surface. This red color part is Gaussian surface. Now tell what is the value of electric field inside this hollow conducting spherical shell. E inside is 0. We have discussed. So our point kon thila, if electric field of Gaussian surface is 0. Now see Gaussian surface bhitar kon achi electric field 0. Electric field 0 means kisi charge nahi. Then flux is also 0. Yes. So in this case E inside is 0 and Q inside is how much? E inside is 0. In this example E inside 0. Q charge present inside this Gaussian sphere is 0, which implies flux is also 0. Ready? So the electric field inside of Gaussian surface is 0, it means flux is also 0. This is one of the most interesting point. Point number 4 and 5 fully important. Yes. Next come to our point number 6. Come to point number 6. That is fully important also. I have told these are the golden points based upon electric flux. Point number 6. This is suppose your Gaussian surface, Gaussian sphere. This is suppose our Gaussian sphere, and let this is your charge Q, outside charge. This is one of the outside charge. Thus, so this is the electric field lines. So point is for outside charge flux is how much? 0. Outside charge our flux is 0 because this is the flux in and this in this through the surface flux is out. Yes. So inward flux is equal to outer flux in magnitude, but inward flux are negative, outer flux positive. So net flux will be 0. So for outside charge flux is 0, but remember electric field is not 0 for Gaussian surface. A point rate as the Gaussian surface road point maybe because of this Q charge, electric field at this point has some value. Yes. Okay. So we can write for outside charge, this is the point. For outside charge flux is 0. For outside charge flux is 0, but electric field is not 0. Electric field is not 0 for Gaussian surface. For Gaussian surface, electric field is not 0 for Gaussian surface. I hope it is clear to all of you. Next come to point number 7. Point number 7. Okay, this is suppose your Gaussian sphere, and here air is present. Okay, so inside charge is suppose Q at center. So what is the permittivity? Epsilon naught. So in this case flux will be equal to Q divided by epsilon naught. In second case, suppose a medium is present. A medium is present within the Gaussian sphere. A medium is present. And the permittivity of the medium is epsilon. Permittivity of the medium is given epsilon. And this is any medium is present. And at the center, Q charge is present. So what is the flux? So flux is equals to, in this case, Q enclosed divided by permittivity of medium. So we can write Q divided by epsilon naught into epsilon r. Yes, and we know what is the value of Q by epsilon naught. Q by epsilon naught we can write phi naught. Let it be phi naught. So this is equal to phi naught by epsilon r. So the point is flux depends on nature of medium inside the Gaussian surface. The conclusion is thus flux depends on nature of medium inside the Gaussian surface. Very good. This is about your point number 7. Next come to last point, that is point number 8. That is also one of the important point. Point number 8. Suppose these are two Gaussian sphere. These are two Gaussian sphere. Let us think that. ठीक. So inside the green color Gaussian sphere, the charge present is Q1 and the permittivity is epsilon naught. This is sphere 1. And in sphere 2, in case of sphere 2, the charge present, that is your Q2 and the permittivity is epsilon naught. So in this case, what is the value of flux through sphere S1? What is the value of flux through sphere S1? Q enclosed by epsilon naught. So through the S1, the charge enclosed is Q1. S1 bhitar kete charge achi? Q1 divided by epsilon naught. And what is the value of flux through S2? So it will be, take up S2, inside the sphere S2, both Q1 and Q2 charges are present. So this will be Q1 by epsilon naught plus Q2 by epsilon naught. This is the answer. Let's come to the second case. Okay. Second case is our this one. In second case, a medium is present, suppose. This is your medium, whose permittivity is epsilon R1. Its permittivity is epsilon R1. Thus, so now tell what is the value of flux through? What is the value of flux through S1 and S2? So flux through S1 bhitar charge kete amar rahila Q1 divided by epsilon naught into epsilon R1 as per the formula. Yes, okay. So flux through sphere S2, that is both Q1 and Q2 charges are present. So the answer will be Q1 divided by medium sadhra achi epsilon naught into epsilon R1 plus Q2 divided by epsilon naught. Yes, okay. Next, come to the third picture. Come to our third picture. Third picture is this is our third picture, and this is suppose a medium is present. In this region, a medium is present whose permittivity is epsilon R2. Let its permittivity is epsilon R2. So what will be the answer? Flux through sphere S1 and S2. Permittivity is epsilon R2. So flux through sphere S1. The answer will be Q divided by Q1. Q1 divided by epsilon naught. And flux through sphere S2. Both Q1 and Q2 charges are present. Q1 by epsilon naught plus Q2 divided by epsilon R2 into epsilon naught. I hope these all 8 points is clear to all of you. Yes. So these are the 8 golden points regarding your Gauss law. Point number 1, 2. Then this is your point number 3. Point number 4 and 5. Then point number 6 and 7. Last one is point number 8. Yes. Next, let's solve some numerical based upon this concept. Yes. So let's start the first numerical. The question is, arrange the Gaussian surfaces shown below in order of decreasing electric flux, starting with most positive. Yes. So देखो चार्टा surface है A surface, this is your, this one is A, and this surface is our B, then this is the C surface, then this is one D surface. So we can see inside the surface A, all the charges are present. Inside the surface A, all the charges are present. So we can calculate flux through A, flux through surface A, that will be equal to how much? Plus 2q plus q minus q divided by epsilon naught, because q enclosed na. So inside surface A total charge enclosed is plus 2q plus q minus q. So it will be equal to 2q by epsilon naught. Then flux through surface B. देखो B surface भितर 2q, both 2q and minus q charges are present. So we can write this is your plus 2q minus q divided by epsilon naught. This is equal to q by epsilon naught. Flux through surface C. Again C. Through the surface C, plus q and minus q charges are present. Yes. So flux will be plus q minus q. This is your q total divided by epsilon naught. So this is 0. And flux through surface D. So inside D, check it. Inside D, only minus q charge is present. So it will be minus q by epsilon naught. So most positive is A, flux through surface A, that is greater than flux through surface B, that is greater than flux through surface C, and that is also greater than flux through D. This is the order. Decreasing order of electric flux starting with most positive. This is the answer as per the given question. Next come to next numerical. So next question. The question is a metallic spherical shell of radius r. This is metallic spherical shell of radius r. Capital R carries a charge capital Q on its surface. On its surface, capital Q charge is present. A point charge Q by 2 is placed at the center. At the center, the charge value is Q by 2 at C. And another charge plus 2Q is placed outside the shell at a distance x. So at a distance x from the center, a charge 2Q is present at point A. So question is, find force on the charge at the center of the shell and at the point A. Yes. So how to solve? Remember, for first bit we can write, so this is your all the charges are spread. The q amount of charge present on this surface. Yes. So it is mentioned that it is your spherical shell, metallic spherical shell. It is mentioned in the given question. This is your metallic spherical shell, and we know E inside metallic spherical shell is 0. E inside metallic spherical shell is 0. So as E is equals to 0, which implies net force on charge at center will be equal to 0. Net force on charge at center will be equal to 0. Net intensity is 0 inside the shell, so net force will be also 0. Next, it is in this bit, it is mentioned, find the force on charge at point A. Yes, find the force on charge at point A. So remember one thing, at the center you can think Q by 2 charge is there, and throughout the surface capital Q amount of charge is present. So we can think the whole charge is concentrated at the center of the sphere. That means the whole charge can be treated to be concentrated at the center of the sphere, that is Q. So at the center we can think total charge is Q by 2 plus Q. At a distance x from the center, another charge 2Q is present. 2 capital Q is present. So this is Q by 2 plus Q. This will be equal to 3Q by 2. So now it is asking force on the charge at point A. This is point A. At point A, 2Q charge is present. So force on charge at point A, this is your force on charge at point A. This is equals to K into 3Q by 2 into 2Q divided by distance square. K Q1 Q2 by R square. The distance is x. So 2 gets cancelled out. देखो 2 cancel हो गया. So next thing is कितना रहा? Small k means 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught. Then 3Q square divided by x square. This is your force on A. Force present on the charge at A. Yes. Next come to your second bit. The electric flux through the cell. So electric flux through the cell means flux formula is Q enclosed within the cell divided by epsilon naught. So as per the given question, enclosed charge is only Q by 2. This is equals to Q by 2. Enclosed charge is Q by 2 only. So Q by 2 whole divided by epsilon naught. So the final answer will be Q by 2 epsilon naught. Q by 2 epsilon naught. This is the value of flux. Answer. So this is about our given question. I hope it is clear. Next come to third question. Yes. So as per the question, a spherical Gaussian surface encloses a charge of, this is your spherical Gaussian surface, this is your charge, encloses a charge of Q, and Q value, Q enclosed value is given 8.85 into 10 to the power minus 8 coulomb. So in first bit it is asking calculate the electric flux passing through the surface. So flux is equals to Q enclosed divided by epsilon naught. So this is equals to 8.85 10 to the power minus 8 divided by 8.85 into 10 to the power minus 12. Bas. No need to write the unit, only you have to find the answer, and at last you have to write the SI unit of electric flux. So this will be 10 to the power minus 8 plus 12, that is minus 4. 10 to the power, minus 8 plus 12, that is plus 4. 10 to the power plus 4 Newton meter square per coulomb. This is the answer. And in bit B, it is asking if the radius of the Gaussian surface is doubled. If the radius of the Gaussian surface, this is our Gaussian surface. This is suppose the Gaussian surface. And it is asking if the radius of the Gaussian surface is doubled. Suppose after doubling the radius, then this is the surface. This will be the surface, red color surface. Again, all of you see inside the Gaussian surface, red color surface, Gaussian surface, the enclosed charge value is Q. Yes. So by doubling the shape or doubling the radius, flux will remain same. A golden point with I. So it is asking if the radius of the Gaussian surface is doubled, how would the flux change? So answer will be no change. Your answer is no change. This is the answer. Next. So our next question is, this is our next question. Our next question is, a uniformly charged conducting sphere of diameter 2.5 meter has a surface charge density of 100 microcoulomb per meter square. Yes. So as per our next question, this is our question. Yes. This is your uniformly charged conducting sphere of diameter. This is the center O. Diameter is 2.5 meter. This is equal to diameter. Yes. So D is equals to 2.5 meter, that is 5 by 2 meter, which implies a radius will be D by 2, that means 5 by 4 meter, and it is given surface charge density sigma is equals to 100 microcoulomb per meter square. 100 means 10 to the power 2, micro means 10 to the power minus 6 coulomb per meter square, so it will be 10 to the power minus 4 coulomb per meter square. So it is asking, in first bit it is asking charge on the sphere, Q question mark. We know sigma is equals to Q by A. So what will be the value of Q? Q is equals to sigma into A. So sigma into A means sigma value, that is sigma into area value means 4 pi r square surface area. Yes. So sigma value 10 to the power minus 4 into 4, pi value 3.14 into r square. R value is 5 by, radius value 5 by 4 meter. 5 by 4 whole square. So after solving, you will get, it will be 1.96 into 10 to the power minus 3 coulomb. This is the value of charge enclosed or charge on the sphere. Yes. So next it is asking total electric flux passing through the sphere. Total electric flux passing through the sphere. So the answer will be, for second bit, phi is equals to Q by A. phi is equal, sorry, q by epsilon naught. So it will be 1.96 into 10 to the power minus 3 divided by 8.85 into 10 to the power minus 12. So after solving you will get it will be 2.2 into 10 to the power 8 Newton meter square. This is the answer. I hope it is clear to all of you. Next. This is our question. So in figure shows a closed surface surrounding some electric charge. So what is the net electric flux through the surface? So in first bit we have to calculate net electric flux. So we know for first bit we can write the answer. Phi is equals to Q enclosed to the Gaussian surface divided by epsilon naught. And in figure minus 6.7 microcoulomb and 3.2 microcoulomb, these two charges are enclosed charges. So we can write minus 6.7 microcoulomb plus 3.2 microcoulomb divided by epsilon naught. So we can take common micro. So minus 6.7 plus 3.2 into micro means 10 to the power minus 6 coulomb divided by epsilon naught. Epsilon naught means 8.85 10 to the power minus 12. So after solving you will get it will be minus 3.95 into 10 to the power 5 Newton meter square or coulomb. This is the answer. So for second bit, is the electric flux directed inward or outward from the surface? So from the calculation we came to know electric flux is negative. Electric flux is negative. So as the flux is negative, so flux is directed inward. So as simply we can write as flux is negative, so flux is directed inward. Flux is directed inward. So this is the answer of this given question. So I hope based upon Gauss law we have discussed different varieties questions. This is mention mark it as question number 1. This is our question number 1. Next is this is question number 2. This one is question number 3. Next this one is question number 4, and at last this one is our question number 5. I hope starting from question number 1 to question number 5, okay, each and every concept is clear to all of you. Yes. So starting from the Gauss theorem, then we have discussed about the 8 golden points. Go through that comment properly. After that solve the numerical, okay, in your own way. Yes. So kindly share this video to your friends, okay, like, share and subscribe to my channel. Thank you. Have a nice day. And in next lecture, that is lecture number 17, we will discuss the numerical based upon the electric flux. Yes. So wait up to that moment. Stay tuned for next update. Thank you. Have a nice day.